Welcome to 3 Steps to Sketch. In this video, we'll walk through the method that we use to graph shifted secant graphs. And the equation will be in this general form, y equals a secant of bx minus c plus d. So the terms c and d will be your evidence of shifts. So look out for those. That's when you'll know to use this method. And a couple of quick notes before we start. The first thing, we of course know that secant is the reciprocal of cosine. And this method relies heavily on that fact. If you're graphing secant, you likely already know how to graph cosine, both unshifted and shifted. And so this method will be very similar to that with one small adjustment in the last step. So this is a great method to use if you already know how to graph cosine. If you don't, you may like to graph this or any secant equation relying on your knowledge of general function transformations. So know that you can take the parent graph y equals secant x and apply all of the transformations. That works just as well. But I do like this method, one, if you already know how to graph cosine, and two, because it has a lot of analysis embedded in the method. And so you learn a lot along the way as you're graphing. All right, the second thing is just a quick note. It is our method for shifted secant graphs. So it's just a modification for our method of graphing the basic unshifted secant graphs. So if you already know that method, this one will be very, very familiar. All right, and I'll post a link to that method in the video description. So if you want to go back to that, you certainly can. All right, so here are our 3 steps for graphing shifted secant graphs. In step 1, you'll find the companion equation, that'll be the cosine equation, and all of the essential information that goes with that. In step 2, you'll plot lightly, or in a different color, that companion pattern, and then take care of the shifts. In step 3, you'll actually create the reciprocal graph. You'll sketch it in and repeat. So let's dig into each of these steps a little bit more. All right, so in the first, here's our general equation again. We're finding our companion equation. So all you'll do is rewrite the equation, but replace the secant with cosine. And here's some of the essential information that we'll be going to find. You'll be analyzing a, b, c, and d. We know that the horizontal transformations are the inputs of the function, so they will be the b and c terms, and here's what we'll find from those. First, we'll note that b tells us how many cycles happen between 0 and 2 pi, and it also helps us calculate the period. Do that using 2 pi over b. We also can calculate the phase shift using c over b, and you'll just want to make sure you're careful with your equation. If it's in this exact form and it has bx minus c, you'll be able to pull out that c term relatively easily. But if you have a plus sign, you'll just need to make note that it's minus a negative term. And we'll talk through some of the examples with that. But just watch your signs. All right, then our vertical transformations are a and d. A gives us the amplitude for that companion cosine graph. So it's going to help us set some of those companion pattern points. And d is going to tell us our vertical shift. All right, after we do that, we'll find our scale labels. And so we do this, if you've seen any of the other 3 steps to sketch videos, in a very similar way. For the horizontal axis, you want to choose a scale by taking the period and dividing by 4. And that'll just make sure that your companion pattern points in step 2 will align nicely with those horizontal tick marks. For your vertical scale, 1 usually works well. All right, and then the last thing you'll want to do in this analysis step is find the asymptotes of your original equation. So there's a very quick and easy way to do this, and this works for any secant equation. All you need to do is take the inputs of the secant function, or that bx minus c, and you set them equal to the parent asymptotes for y equals secant x. Okay, so those happen at pi over 2 plus pi k, with k being an integer. And if you need confirmation of that, just put that into an online or regular graphing calculator, and you'll see that's where the asymptotes happen. So basically, we're applying the horizontal transformations to the original vertical asymptotes. Okay, and so you'll solve for x, and that will give you the equation for all of the asymptotes of your graph. And again, k is an integer, just substitute in different integers, and you'll get different asymptotes along the graph. So that's step 1. It's the bulk of the work, the bulk of the analysis, but you really put in a lot of work in this first step so that all of the graphing steps are very seamless. All right, so in step 2, we're plotting our companion pattern and then we'll shift it. So you'll do this, like I said before, lightly because we're using this to build our final graph of secant. All right, so like I said, we are graphing our companion function here, still working on that cosine equation and creating the reciprocal graph in step 3. So recall the pattern for cosine graphs, starting on the y-axis with a maximum. Then at the first horizontal tick mark, you'll have your first 0 or x-intercept. Then you'll have a minimum at the next horizontal tick mark. And then you'll finally have your last 0 or x-intercept. And you find these, just a quick reminder if you aren't familiar or maybe you've forgotten the cosine pattern. Here's where this happens. So the max is, like I said, on the y-axis at 0, a. That's where you get the y coordinate, just from that value a from the equation. First horizontal tick mark gets that first 0. The minimum, find that y-coordinate value, just taking the opposite value of a. And then the third horizontal tick mark will be that second x-intercept. And so a quick note on this is when your a is positive, and the only thing that switches when your a is negative is that the max and the min switch names. You still use the above method, and it will give you the right points every single time. All right, so once you have those first 4 companion pattern points, then you apply the shifts. And remember, before we said our phase or horizontal shift will just be C over B, and your vertical shift will be D. And so usually you can just take your originally plotted points and shift them both ways, so horizontally and vertically, in the same time. I usually mark these as X's, and we'll see that in many worked examples that I'll post soon. All right, so step 3 is where we actually create the reciprocal graph. We build off that intermediate companion graph. Okay, so our maximum, that first point, will become a local minimum for the secant graph. So that's the maximum of the cosine companion. The first 0 will turn into an asymptote. And if you think back to the basic principles of how cosine x and secant x are related to each other, when cosine x is equal to 0, if you try to take the reciprocal of that value, you end up with 1 over 0. And that's what creates that vertical asymptote, that undefined value. So that's a good way to kind of remember that those 2 points go together. The minimum from the cosine companion graph will become your local maximum for your secant curve. And then the second 0 will be your second asymptote. So easy enough. Then you'll sketch in your graph and repeat it for as many cycles as you need for your particular equation. So now let's go ahead and look at a template that keeps all of this organized. I use this template for every single equation of secant that I graph. Okay, and it just helps keep everything organized. So you see all the steps there. Since we aren't working a specific example, I'm not going to fill out this template, but again, I will post a lot more worked out examples for shifted secant graphs, so definitely check those out. But in general, let me just show. So you do all the analysis. You would label your horizontal and vertical axis. So let's just say A, negative A. And we won't even label those horizontal tick marks, but we know our companion pattern for cosine would look roughly like this. And let's just say that the shift was left 2 horizontal grid units and up 1 horizontal grid unit. So you'd move each of your points left 2 and up 1. This is just an example. Of course, you could move it any which way depending on what your shifts are. But you can see this cosine curve right here. Okay. So this kind of briefly showed step 2. And hopefully that gives you a better understanding of how you plot that companion cosine pattern and then shift. And then when you create that reciprocal graph in step 3, remember we say that our maximum from our cosine graph turns into a local minimum for your secant graph. So it's kind of building like that. The original zeros from the cosine graph become vertical asymptotes. So I'm going to go ahead and do both of those right here. And then the minimum from the cosine graph, that companion, that becomes a local or relative maximum. So you have our secant curve coming in like that. And of course, in our next cycle, we have another local minimum. So you could kind of see the secant curve continuing there. So in general, this is what it'll look like. Like I said, I'll post a lot more worked out examples, so be sure to check those out. But hopefully this gives you a really good foundation to build on when you're graphing the shifted secant graphs with the 3 steps to sketch method. Thanks for watching, and good luck with your graphing.